So this is the start of the 1.4 part 2 notes. We are going to solve a system of linear equations, but this time we're going to do it with 3 variables, and therefore we have 3 equations. So just like system of 2 variables, the solutions are when all of the equations would have the same answer that would satisfy each equation. So we need to find the values for x, y, and z that satisfies each of these equations. So first, we're going to do the elimination method, and when I do these methods, I like to number number my equations. So I number that 1, 2, and 3, so I can label steps as I go. You don't have to number them, but I'm using the numbers to show you how I do it. And when I do it, I use the numbers just to keep organization. These problems are a little longer than solving the system of 2 variables. So what I want to be able to do with elimination, just like solving 2 variables, I want to be able to add 2 equations together and a variable to zero out. And so I want to get rid of a variable. So that's hence the eliminating, okay? And I'm just going to pick a variable. I'm going to start by eliminating x, okay? So I'm going to take the first 2 equations. I'm going to take equation 1 and equation 2. And I want to be able to add those 2 equations together to where x will go away. So one of them is a positive 1x, the other is a positive 2x. So I need to multiply one of those equations by something so x can add up to 0. And so if the bottom one is 2x, if the top one would be negative 2, then they would cancel out to 0. So I'm going to multiply that first equation by a negative 2. So every single term in that equation has to be multiplied by negative 2, and I'm going to rewrite it doing that. So I have negative 2x minus 4y plus 6z equals negative 22. So that was taking each of these terms and multiplying it by negative 2. Then I just want to leave the second equation the same. So 2x plus y minus 2z equals 9. Notice I keep the x's all lined up, the y's lined up, the z's lined up, and the constants all lined up. So that way when I add these together, the x's now are gone. I eliminated them. I get negative 3y plus 4z equals negative 13. Okay, so this made a 5th equation for me. So I'm going to number this one 4. Made this equation number 4. But I'm not done eliminating x yet. So I need to do something now with this 3rd equation to get rid of x. And so I just need to pick one of the other 2 equations. It doesn't matter if you pick 1 or 2. I'm just going to pick 2 because then I can multiply by a smaller number. So if I take equation number 2 and I multiply it by a negative 2, that gives me a negative 4x, and a positive 4x added together will cancel out, eliminate that 0. So I want equation 2 times negative 2, and then I have to just write equation 3 out. So all of equation 2, every single term needs to be multiplied by negative 2. So I get negative 4x minus 2y plus 4z equals negative 18. And then I'm just going to write that 3rd equation, just leaving it all the same. So 4x plus 3y plus z equals 16. Now when I add those up, my x's are eliminated. They add up to 0. I add up my y's. I get a positive 1y plus 5z equals a negative 2. All right, and so now I'm actually going to I'm going to number this equation 5. So now I have equation 5. I have an equation 4. And now I have those 2 equations, And that makes a system with two variables. So that's like 1.4 part 1, where we just solved a system with two variables. So I want to be able to eliminate either y or z here. And if I pick, looks to me like if I pick the y's, I can multiply the equation number 5 here by a positive 3, and my y's will be eliminated. So I'm going to take equation 4, and I'm going to leave it the same. Didn't change anything, didn't multiply by anything. But then I'm going to take equation 5, and I'm going to multiply it by a 3. This is why I number my equations, just so I can write down what I'm actually doing in case I ever have to go back and kind of check my work and see, well, how did I get that? That's all I'm doing with these numbers of my equations. So anyways, all right. So I'm going to take equation 5, I'm going to multiply it by 3, so I get 3y plus 15z equals negative 6. Now when I add up those two equations, the y's are canceled or add up to 0. They don't just disappear, they add up to 0. 4z plus 15z is 9z. And negative 13 and a negative 6 add up to a negative 18 or 19. Sorry, I'm just making up things here. All right, and so if I finish solving for z, I'm going to divide by 19, and I end up with z equals negative 1. All right, so that's part of my answer. I found z, but now I need to find x and y. So we're going to kind of work backwards. I'm going to take this z, and I'm going to put it into either equation 4 or equation 5. Doesn't matter which one. This one has no coefficient in front of y, so I'm just going to plug it in there. So I get y plus 5, and we said z was negative 1, equals negative 2. So I rewrote equation 5, and I just substituted in z. And so I get y minus 5 equals negative 2, add 5 to both sides, and I get that y is 3. So now I have z, I have y, and I'm going to take both of them and substitute them into one of my original equations. Doesn't matter which one. I'm going to pick the top one. It just has, no coefficient in front of x, which is what I'm trying to solve for. So I end up with x plus 2 times y, and we just said y was 3, minus 3 times z, which we said was negative 1, and that equals 11. So I have x plus 6 plus 3 equals 11, x plus 9 equals 11, subtract 9 from both sides, so x is going to equal 2. So now I have found all three variables. I have x, I have y, I have z, but you write your final answer here, if I can zoom out here somewhere, write it as a point. You have 2 is the x value. It's always x, comma, y, comma, z. All right? Just like our other points when we did the two variables was x, comma, y. So we said y was 3 and z is negative 1. So this is my final answer. Go on to the next video to see example number 2.